Let us see how to use the Oracle Autonomous Database to build a machine learning model using SQL and PL SQL. So this is an autonomous database instance, and this is in my tenancy in the Oracle Cloud. You can reach the service console by clicking this button. It will take you to the service console, and in the development tab, we have the options to launch SQL Developer Web, which is a web-based interface of SQL Developer, and Oracle Machine Learning Notebooks, which is an Apache Zeppelin based user interface for data scientists. Going to the SQL Developer Web, I'm just executing a query on the table that I'm going to use for this exercise, which is in the schema Deepak. The table is churn modeling. You can see there are about 10,000 records. And to see what's in the record, let us pass on this query, which is going to show the first 10 records. And you can see, this is some customer data with their credit score, geography, age, tenure, balance, number of products they have a credit card or not, are they active, and what their salary is, and whether they have churned or they're still with the organization. So we're going to build a model using this data set to predict churn so that the organization can use this model and identify customers who are at risk, and then do something to retain them. So now this is the OML notebook interface, which as I showed in the service console, you can launch from there. And here you can create notebooks, you can create jobs and schedule notebooks, and you can also run your SQL statements or SQL scripts. There are a lot of examples here which will help you actually start using this. Let me open the notebook that I've created for churn modeling. Right, so you can see here, this is an Apache Zeppelin interface. So in this paragraph, I'm executing a SQL statement, and it is able to run a SQL statement in the Oracle database itself. So you're just avoiding a redundant compute here. You're not spinning up a separate compute instance to run your queries. It is executing natively in the database. And just to check the spread, you can see about 7,963 customers still with the organization versus the 2,037 who have exited. I've created a view and I've selected the columns which are relevant for this particular use case. And you can see you can execute a PL SQL script as well in the same notebook interface by just passing a different handler. So it's a mix of SQL and PL SQL in the same notebook. And I'm just querying the view, showing the top 10 rows, splitting the data set into training and testing. I'm using 80% for the training data, and I'm using the rest for my test data. So it's creating two views, train data and test data. And another PL SQL script, which is using the DBMS data mining package. This comes part of the Oracle Advanced Analytics add-on for the Oracle database, which gives you capabilities to build machine learning models natively in the database. So with the DBMS data mining, I've set prep auto to on, which is going to prepare the data by itself by identifying the profile and spread of the data and the type of data. And it is going to fix the data, balance the data set by itself. And I'm choosing a support vector machine algorithm. There are various other types of algorithms that are actually supported by this package, and there's good amount of documentation for this, which will tell you what kind of algorithms are supported and how to use it and the parameters and everything. So the Oracle documentation is quite detailed for this. Right. So yeah, building the model using the create model to method, and it has built the model. Now I'm just checking the model, the attribute name and the type that the model is using, which is telling you what kind of data it is, and the algorithm that is being used, just verifying that. So it is support vector machines. So model setting, you can either use the default model settings or you can create your own model settings. The Oracle documentation, is will outline the two options as well. I've used the default model settings here, so it is just telling you, what it is used. And now I'm applying the model to the test data, and I'm computing a lift chart. So the data mining, DBS data mining to apply is going to apply that, the SVM model to the test data, and this is the cast ID, and this is the table that where the results will be stored, and this is the schema. And I'm computing lift, so I'm using the result table and the test data, the customer ID, which is the unique ID per record, and the target variable here is exited, and the results are going to be stored in the lift table, and these are the metrics, the prediction and probability metrics. There you go, you can see the lift chart here, and again this is just a SQL statement. And one good thing about the Zeppelin notebooks here in the OML is you have embedded visualization options, which just in a click is going to transform your query output into visualizations, which is quite handy. So I'm building an ROC curve here. Again, DBMS data mining has a compute ROC method. I've passed in the parameters required. The Oracle documentation has detailed steps and details about all the parameters required. So the area under the ROC curve is 0.83, so it's quite good, and this is the ROC curve. Now let us see a confusion matrix. So data mining's compute confusion matrix is another method which I've used to compute the confusion matrix, and the accuracy is 0.84, so 84%, which is really good, but yeah, with some more data. This is just for demo purposes. And this is the confusion matrix, so you can see there's about 54 plus 246, which is about 300 records have got wrong predictions in the test data, so in the 20%, which is 2000. So a query to actually see the customers who are likely to churn with a probability of greater than 50%, 0.5. So you can see there are about 197 customers who have been predicted to churn and has a probability greater than 0.5. You can even query who the customers are. You can see what the customer ID is. And FYI, all this is happening in the Oracle database where the data is, right? You're not extracting the data out to a different environment to model this. So there's also an option to real-time scoring. So you can just use, in your SQL statement, you can just use prediction probability and, pass in the model and, just simulate your record, and then it is going to give you the prediction. So here I'm computing the prediction for I'm telling that what is the probability, give me the probability for this particular record to have a churn prediction of 1. It is telling the probability is 0.011%. If I just change this to 0 and compute this again, it's pending. Yeah, it's running now, and it's going to give me the probability for the customer as not churn as 98.9%. So this customer is a good customer, safe. There you go, mission accomplished. I hope you guys enjoyed. Thank you.